Welcome to the channel. This is our 35th discussion on the subject of painting defects, their causes and countermeasures. We shall be talking about another important paint defect, and that is known as rail dust. These are the detailed titles. It includes photographs and illustrations, rail dust definitions, their causes and countermeasures, repair method, and motorcycle specific risks and countermeasures, and automobile specific risk and countermeasures. Here are the photographs of rail dust. In general, rail dust is small colored bumps or specks in the surface of a paint film. This is the illustration regarding this defect. Rail dust is a common paint surface defect caused by tiny iron oblique steel particles, often from rail transport, brake dust, or nearby metal industries, setting on painted surfaces. These particles embed into the paint and later oxidize, resulting in the rust appearing as a small orange-brown specks on the coatings. The key points are sources are rail transport, brake dust, industrial fallout. Appearance, fine rust-colored dots on a paint. Damage mechanism, embedded iron oxidation and then staining and pitting. Typically on automobiles, motorcycles, and industrial painted parts. The rust color comes from the oxidation of embedded iron particles. The typical appearance of rail dust is as follows. Fine orange-brown or reddish dots may feel slightly rough to the touch, commonly visible on light color paint, can appear days or weeks after painting. Rail dust appears as rust-colored specks. They are visible on or just beneath the paint film. The common root causes are deposition of airborne iron oblique steel particles from rail transport of painted parts or vehicles, brake dust, nearby metal cutting, grinding, or welding operations. Oxidation of embedded particles when exposed to moisture and oxygen. Its stage of occurrences after painting, during transportation, during storage, or outdoor exposure. Regarding inspection and detection method, first come first, that is visual inspection under natural or white light, that is D65. Focus on horizontal surfaces and leading edges. Tactile inspection, slight surface roughness, light hand feel, or inspection glove to detect micro roughness. In detail, textile inspection can be explained as it means feeling the painted surface by hand or with a glove to detect roughness or raised particles that may not be clearly visible, such as rail dust contaminations. Confirmation using iron reactive chemical test. Iron reactive chemical test uses a special solution that reacts with iron particles on the paint surface, causing a visible color change, usually purple or red, confirming the presence of rail dust or ferrous contamination. Another inspection method could be chemical confirmation test, that is, apply iron reactive fallout remover. Color change purple/red confirms presence of ferrous contamination. Next comes magnification, which is optional, hand magnifier or stereo microscope to differentiate from dust nibs, that is, raised bumps. Regarding quality and acceptance criteria related to rail dust, that is, no visible rust color specks allowed on Class A surfaces. Any confirmed rail dust contamination requires corrective action. Coming to the causes and countermeasure. Number one probable cause would be rail transportation fallout. That is, vehicles transported by rail are exposed to airborne iron particles generated by friction between train wheels and rails. That is, microscopic ferrous particles settle on the paint surface during transportation when exposed to oxygen and moistures. These particles oxidize, forming rust-colored specks embedded in or bonded to the paint film. The recommended countermeasure is use protective wrapping, VPI paper, or PE film immediately after painting. Priority actions are prefer enclosed rail wagons or containers where possible, minimize dwell time on rail yards, apply temporary protective wax or sealant before dispatch. Here, VPI paper means volatile vapor phase inhibitor. This paper is a protective wrapping material that releases corrosion inhibiting vapors, which prevent rusting of metal particles and help protect painted surfaces during storage and transport. The second probable cause could be open storage near rail lines. That is, painted vehicles or parts stored in open areas and close to the rail tracks. Continuous fallout of iron particles from a passing train increases surface contamination risk, especially on horizontal panel. The recommended countermeasure is store painted units in covered or enclosed area. The priority actions are maintain safe distance from rail lines, reduce outdoor storage duration. Number third probable cause could be industrial atmospheric fallout, that is, proximity to steel plants, welding, grinding, or machining operations. Airborne ferrous dust travels and deposits on paint surfaces, later oxidizing under humid conditions. The recommended countermeasure is improve site layout and zoning. The priority actions are install air filtrations, and dust barriers. Cover painted parts during storage. Fourth probable cause could be high humidity and moisture exposure. Exposure to rain, condensation, or high humidity immediately after painting. Moisture accelerates oxidations of embedded iron particles, making rail dust visible sooner and more severe. The recommended countermeasure is ensure complete curing before outdoor exposure. And the priority actions are store in dry, covered environments, use dehumidification where possible. Fifth probable cause related to the rail gas defect is delay in surface protection. Lack of timely wax, sealant, or protective coating after curing. That is, unprotected clear coats allow easier embedding and oxidation of iron particles. The recommended countermeasures are apply protective wax or sealant soon after curing. The priority actions are implement standard post-paint protective SOPs. The next important cause could be inadequate packaging during transport. Incomplete or damaged protective covers during shipment. Gaps or torn packaging allow iron dust to reach and contaminate painted surfaces. The recommended countermeasures are inspect packaging integrity before dispatch. The priority actions recommended are use robust rail transport approved protective materials. The seventh probable cause could be poor housekeeping in storage areas. Dust accumulation on floors, racks, and handling equipment. Settled ferrous dust can be resuspended and deposited onto paint surfaces during handling. Therefore, implement strict housekeeping schedules. The priority actions are regular cleaning of storage handling areas. There is a special note regarding rail dust. When correcting rail dust on base coat, apply clear coat finish by sanding or buffing. A minimum remaining clear coat thickness of 2 millis, that is about 50 microns, must be maintained to ensure adequate ultraviolet protection. If the correction process is expected to remove more than zero point 0.5 millis of clear coat, refinishing is recommended. Zero point 0.5 mils mean about 12 microns, rather than further material removal. Commit the repair method related to the rail dust. To start with, confirm the defect. Inspect the affected area using 30 into magnifying glass, 30 times magnifying glass to verify the presence of rail dust contamination. Handle the surface carefully during inspection to avoid introducing scratches. Then, initial cleaning. Wash the vehicle thoroughly with soap and clean water. Rinse completely and dry the surface. Thereafter, surface preparation. That is, clean the area using an approved solvent-based surface cleaner to remove oils and residues. Then, chemical decomposition. Apply an acid rail dust iron fallout remover strictly according to the manufacturer's recommendations or instructions. Allow the product to react as specified. Then, rinsing and reinspection. Rinse the treated area thoroughly with cold water. Inspect the surface to confirm removal of all iron particles. Thereafter, repeat the chemical treatment in case contaminations are still there. Then, mechanical correction subject to requirement. If the paint surface shows pitting, lighting sand using lightly sand using 1200 grit or finer sandpaper, compound and polish the area to restored surface gloss. Refinishing. In case of severe cases, if damage cannot be corrected without excessive film removal, sand and refinish the affected part in accordance with the finishing standard. Now, we have a special subject that is motorcycle specific risk and countermeasures. In case of rail transportation fallout, motorcycles are often shipped or partially assembled with exposed painted parts, increasing direct fallout risk. Adopted countermeasure could be manually mandatory full body protective wrapping, especially tank, fender, and side cover, etc. Apply temporary protective wax before dispatch. In case of open storage, small components of motorcycles and scooters are frequently stored on racks or trolleys in open areas. Therefore, covered racks with dust-proof curtains reduce rack dwell time. Inspection sensitivity. Small rust specks are highly visible on tanks and fairings. Early inspection within 24 to 48 hours post paint. Iron reactive test on suspect lots. These are the recommended countermeasures. Regarding industrial fallout, motorcycle plants are often closer to the machining and welding lines. Countermeasures are physical separation and curtains, local exhaust ventilation near metal processes, and finally, handling frequency. In case of motorcycle, higher manual handling increases chance of dust transfer. Therefore, use clean glove policy, dedicated painted part handling zones. The clean glove policy, as mentioned here, is a shop floor rule requiring operators to wear clean, lint-free gloves when handling painted or finished parts. Purpose: prevent transfer of dust, iron particles, iron, oils, and sweat onto the painted surfaces. Reduce defects such as rail dust, fingerprints, stains, and scratches. In practice, gloves must be changed frequently. Soiled or dropped gloves are not reused. Separate gloves for painted versus unpainted parts. Fairings or painted fairings of the motorcycle parts mean painted outer body panels of a motorcycle that cover or surround the frame, engine, or front assembly. Purpose: improve aerodynamics, protect components from wind, dust, and debris, provide the visual styling of the motorcycle. Example: front fairing, around headlamp, side fairings, full fairing in sports motorcycles. Now, coming to the automobile specific risk and countermeasure in case of rail dust. Transportation fallout. Rail transportation fallout. The risks are: finished vehicle transported long distance by rail with extended yard dwell times. Here, what we recommend is enclose rail wagons where possible, temporary protective film on the horizontal panels. In case of yard storage, vehicles park in open rail yards for days or weeks. Here, what is recommended is limit outdoor storage duration, prefer covered yards or carports. Third aspect is that of humidity and weather. Large horizontal surface trap moisture, accelerating oxidation. Therefore, what should you do is weather monitoring SOPs, avoid shipment during extreme humidity where feasible. Coming to packaging integrity, partial covers may shift during transport. Therefore, in case of automobiles, pre-dispatch packaging audit checklist, reinforce edge protection. And finally, post-arrival detection. Automobiles. Defect may appear after dealership delivery. Here, recommended countermeasures, adapted countermeasures are rail dust inspection at PDI stage. Number two, standardized decontamination process at yards. Coming to with this background, what is the key difference? Motorcycles, higher exposure and handling risk, focus on wrapping, early inspection, and separation. In case of automobiles, higher logistics and dwell time risk, focus on yard control, protective films, and PDI inspection. This adaptation supports OEM level differentiation between two-wheeler and four-wheeler paint operations. Rail dust should be treated as controllable logistic-related contamination defect, not a paint quality failure. This is another opinion. Correct identification, controlled exposure, and conservative correction are essential to preserve coating durability and appearance. With this, we conclude our today's discussion on the subject of rail dust. Our next topic would be effect number 36, that is runs oblique sags. Thank you and thank you very much.